Welcome to section 7.4, and it's entitled Complex Rational Expressions, sort of implying that the stuff that we've been doing isn't complex, which is kind of laughable. Section 7.3 was kind of difficult. It was complex, but in the world of mathematicians and mathematics, they call complex rational expressions something where you have an expression that has a fraction within a fraction. That's what makes it complex, having a fraction within a fraction. So if you take a look at this guy right here, this is complex. The reason being is, this big fraction right here with the denominator and the fraction symbol right in the middle, it has in its numerator a fraction, and in the denominator it's a fraction. And the fact that there was two fractions is immaterial. The fact that there's somewhere in the numerator or denominator, not necessarily both, but it can, in this case it's both. If you have a fraction in the numerator and denominator of a big fraction, then it's complex. So let me copy this thing and see how to solve these things. Q over 5. And I'm going to exaggerate the fraction for the overall fraction. So we have q to the 5th over 15. And so what do you do to solve this thing? Well, it's not all that hard. It looks more intimidating than it is. Now, you're not going to hear these terms in an official math book. But what I think people like my idea of this of the description of a complex fraction. People have at least gravitated toward it. This overall fraction I call the mother fraction, and the mother has in itself a couple of babies, baby fractions. So these guys here I call the baby fractions down here, and the mother is the one that contains those babies. So what you're going to do is, of all the baby fractions you see, find the lowest common denominator. The same way you find the lowest common denominator in the previous section. Take a look at the 5 and take a look at the 15. What's the lowest common denominator of 5 and 15? Think about it. I think it's 15. 15. Lowest common denominator is 15. So what do you do with that 15? What you do is, relative to the mother, you're going to multiply the top and bottom of the mother by 15. Now you're going to say, okay, as long as you multiply a fraction, numerator and denominator, by the same number, it doesn't change its value, but it will radically change the way this complex fraction looks. Now, take a look at this thing. You're going to say 15 times q over 5. That's basically saying, let me put it down here. Say you're going to multiply the tops, 15 times q over 5. And what's that going to be equal to? I guess 5 goes into 15 3 times, 3q. Okay. Now, I could have got that 3q a lot quicker than what I just showed you here. Rather than just multiplying the tops and then dividing by the 5, why don't we just say 5 goes into 15 3 times? Okay, in other words, 5 goes into 15 3 times, and then you'll have 3 times q. All right, so that's equal to, well, here's another way I like to explain it is, let's circle this number and point to the fraction it multiplies. Okay, 5 goes into 15 3 times. So what happens is that 3 will meet up with the q to get 3q as your answer. Let's do a circle and point technique for this fraction now. 15 goes into 15 one time. So this arrow meets up, the value of this arrow is 1. It meets up with the q to the 5th to give you q to the 5th. Now, this fraction is equivalent to what we had here, but with no baby fractions. It's not quite the answer, because you need to simplify your answer. That's a q, and that's a q to the 5th. What's going to happen is one of these q's cancels out one of these, is that. So what I'm going to do is put that answer into the box, nice and pretty. 3q raised to the 4th power, and that's a nice, that value here should be the answer. Great, fantastic. Okay, let's see what the next one looks like. I'm going to do the same one. That's an easy one. I'm going to do another one. Let's do this one. This is better. Number 3. Number 3. Let's get rid of this. Don't save it. File, new, okay. Let's come over here and say, well, here we have 6 plus 5 over m divided by 6 minus 5 over m squared. Okay, that looks complex. That's an m squared. Let me make a better squared. Sorry about that. Let's make a better squared. That should be squared. Okay, that's a squared. Now, what do? Here's the rule. For all the baby fractions you see, and I only see 2 of them. 6 is not a baby, it's not a fraction. But this guy right here is a fraction, and this guy here is a fraction. Those are the babies of the overall mother. Of all the babies, find the lowest common denominator of the babies. M squared. Well, what would it be? The lowest common denominator has to have an m, and you always take the highest power, so it's m squared. That's the answer. So what you're going to do, remember what pluses and minuses do, they make bundles. And what you're going to do now is multiply the top and the bottom of the mother by the m squared you told me, well, I told you, this is a video, that is the lowest common denominator of the babies. Now, here's how you do this. And this is why I like this circle and point approach to solving this. Circle, point. Okay? Now, what that means is forget about all this stuff in between. Just focus your eyes on these 2 things. What is that equal to? Well, there's no fraction here, so I guess it's simply 6m squared. 6m squared for that guy. I copy the plus. I circle and point to this guy. That's a fraction, so what's going to happen is, m goes into m squared. How many times? I guess it goes m times. So this arrow represents m meeting up with the 5, giving you 5m. That's it. So it's starting to look better already. Starting to look better already. Now let's do the same thing over here. Circle, point. Same deal. 6 times m squared. There's no division here. There's no fraction. So it's 6m squared. Just copy the minus. And then circle and point these 2 guys. And that's the whole idea behind the circle and point is it just focus your eyes on what the multiplication you want to have. Here the m squares will cancel. That m squared and that m squared cancels because this m squared represents something on the top of a multiplication. This is on the bottom. They cancel, leaves you with 1. 1 times 5 is 5. Now before we enter that, it's starting to look good. There's no fractions in there. Before we start entering it, is there something that we can do to simplify it? Now remember, this is a bundle. Don't start forgetting the stuff that we learned earlier, where you just don't go ahead and cancel out the m squares because you want to, because they can't, because that's inside a bundle, and you can't take, you can't go inside a bundle and pick off the stuff you want to get rid of. You have to either get rid of the whole bundle or not at all. The way to do that is you factor, and the problem is I can't really factor the bottom guy. Can't do much with that. I suppose I could pull out an m here, but that's not going to help you because you're not going to be canceling that bottom bundle, so because that's a plus there. So I'm going to say that's the answer right there. So I'm going to put that right there. Let's make a fraction. I don't need the parentheses because that bundle is not being multiplied by anything else. Square it. Put a plus 5m up top. And on the bottom, I'm going to say 6m square that minus 5. And don't overthink it. Check your answer. Nice work. Fantastic. There's not many problems here. Not too many problems over here. Okay, let's do this one here, number 4. And I think I can just probably save a little time and use the same canvas. What I'm going to do is say 1 minus 4y squared over x squared divided by 3 plus 6y over x. Okay, take a look at this. This is the mother fraction. The mother fraction apparently has 2 baby fractions. Okay, I don't care where they are. The fact that they're there, that the mother is holding on to one on the top and one on the bottom, there's just 2 fractions. Of all the baby fractions you see, what's the lowest common denominator? So I look at this denominator, x squared and x. It looks like it's x squared. Now, what do you do with that x squared? You're going to multiply the top and bottom of the mother by x squared. Now, when you do that, remember, this is a bundle, and this is a bundle, because that's what pluses and minuses do. And you're going to multiply top and bottom by x squared. Okay, that's equal to. Circle, point. Okay. It's got to get our answer ready right there. Circle, point. Well, 1 is not a fraction. It's a straight multiplication. X squared times 1 is x squared. Minus. Circle and point. Well, this is a fraction. A fraction is a division. This x squared divides into x squared 1 time. 1 times that 4y squared is 4y squared. Okay, that's cleaned up on the top already. Let's do the bottom here. This is going to be circle and point. Every term that you see, top and bottom, 3x squared. There's no fraction in 3, so nothing divides out. And then what do we got here? What we got here is, let's see, this x divides one of these x's, leaves you with an x. That's an x that meets up with the 6y. So that's going to be plus 6x and a y. That's what we got. So at this stage, it's starting to look real good because there's no more babies. Okay, now what we're going to do next is say, geez, this looks too, whenever you see a difference of 2 squares, it seems like we should be able to factor it really quickly. So let's try to factor it. See, right now, that's a big bundle, and that's a big bundle, and nothing cancels. So we need to factor things, and so this is going to be x, and x gives you the x squared. Of the difference of 2 squares, I get plus and minus for the terms, and the thing that's being squared to get 4y squared is 2y and 2y. The bottom. What can we do with the bottom? You know what we can do with the bottom? I can pull out a 3. I can pull out an x. And we're left with, when I pull out a 3 and an x, 3 goes into 3 once. Squared, we pulled out 1x, leaves you with an x. Plus, 3 goes into 6 2 times. I pulled out the x, and it leaves me with the y. Now again, multiply through, you'll convince yourself that that's right. Now, this is the beauty of this problem. Look at this. This bundle and this bundle are the same, top and bottom. We can cancel those out. And what's left over, right there, is the answer. But I'm going to put it right in here in this box because it looks a lot better inside the box. As a fraction, x minus 2y. No need for the parentheses because it's not multiplying anything. Divided by 3x. It's got to be the answer. It's got to be the answer. Let's see if that's right. Is it the correct answer? Check my answer. Yeah. So these complex expressions aren't as complex as they claim they are. Let's see. That looks good. Let's do that one. Don't save. File. New. Start over again. We come over here and we say 3 over, let's start over again. I want to give myself a little room for my arrows. So let's start over again. File, new. Okay. Let's come over here and say 3 over y minus 1/8 divided by 8 over y minus 1. Now remember, this is a bundle, and that's a bundle. That's good. Okay. Well, the mother fraction has 3 babies. 1, 2, 3. Of all the babies, what's the lowest common denominator? Well, the lowest common denominator has to have a y in it, and that's the highest power y I see, and it's also have to have the 8. So I'm going to say 8y. Top and bottom. Let's make a better looking y. 8y. Okay, top and bottom. So I'm going to make the answer over here. Now circle and point. Circle, point, boom. Y's cancel. Y divides into y, cancels, leaves you with 8. That 8 meets up with the 3 to give you 24. Copy the minus. Circle and point this. The 8's cancel. What survives is the y. That multiplies the 1, and that'll be 1 times y, which is a straight y. Okay. Let's circle and point this guy. Y's cancel. Y's cancel. Leaves you with 8 on that arrow. 8 times 8, 64. Copy the minus. Now, this circle and point, there's nothing that cancels because there's no denominator in y. So it's 8y times 1 is 8y. Now, this is a big bundle, and that's a big bundle. This bundle here can't be factored. This can't be factored, so that's 1 unit in itself. I can pull out the 8, but that's not going to help me, because that's not going to cancel. I'm not going to generate a term that will cancel out the 24 minus y bundle, so that's your answer right there. That is your answer. I'm going to come over here and divide. I'm going to make a fraction, 24 minus y, and this is going to be 64 minus 8y. Check that answer. Excellent, excellent, excellent. Oh, multiple choice. You got 1 out of 4 chance to get this right. Okay, let's take a look at that. Let's take a look at that. Let's get rid of this. We don't need that anymore. Don't save that. File, new, canvas, new canvas. And I'm not even going to look at the answers. Don't even look at the answers. Just do it the same way we had before. 1 minus 7 over the bundle y plus 2. Okay, divided by 7 plus 1 over the bundle y plus 2. Okay. This is a big bundle, and that's a big bundle. And that looks like let's close that off. That looks like a 6y. It's a bundle, y plus 2. What I'm going to do is look at all the baby fractions. These are the 2 babies. The common denominator of all the babies looks like y plus 2. Remember, the lowest common denominator has to have every factor you see listed once, highest power. And y plus 2 fits the bill. Same thing here. Multiply top and bottom of the babies, of the mother, I'm sorry, by y plus 2. And let's see if I can give myself a little bit more space here. Yeah. Equals. I'm going to get my answer ready. Right there. Circle, point, boom. Focus your eyes on those 2. 1 times that bundle is simply, well, y plus 2. Okay, copy the minus. Circle and point. Now what's that equal to? Y plus 2's will cancel. Those factors cancel. When they cancel, leaves you with 1. 1 times 7 is 7. Okay, circle and point the bottom guy. Ooh. Now this guy, y plus 2 times 7, nothing cancels because there's no fraction on the 7, so it's simply 7 times y plus 2. And we'll leave it like that for now. Copy this plus, circle and point this guy, and the y plus 2's will cancel, leaves you with 1. 1 times 1 is 1. So at least this thing looks like an expression with no babies. The babies are gone now, but we have to clean that up. Because certainly 2 minus 7 has to be y minus 5. And the bottom, we have to multiply through the parentheses, get rid of it, liberate these terms. That's 7y plus 14 plus 1. That's a plus here, okay. And these two guys give me 15. Y minus 5. And this is 7y plus 15. I'm going to look for that in my answers. I see it right there. Too coincidental. It's got to be right. See it right there. Check your answer. Nice. Nice work. Now I'll do 4 more. Let's see what... Ooh, this looks complicated. This looks sort of complicated. Let me just do a quick scan of what the next ones are. Okay. Okay. All right. Let's do number 7. And I'm going to do this with a new sheet of paper, file, virtual paper. Okay, some electronic paper. Okay, and we get to pick one. Okay. Well, let's see. We have x divided by x plus 4, and make a bundle out of that. Minus 3 over x, big division, x over 2. Now this is a big bundle right over here too, because that minus takes those two fractions and bundles them together. Well, let's take a look at this. We have 3 babies. The lowest common denominator of those 3 babies has to have a 2, it has to have an x, and it has to have this bundle. So 2x, x plus 4. Okay, so I'm going to multiply the top and bottom by this lowest common denominator. Copy this down to top and bottom of the mother. Okay. That's equal to, get the answer ready, circle, point. Okay, focus your eyes on those two. The x plus 4's cancel. X plus 4's cancel. What survives is 2x. 2x meets up with this x. 2x times x is 2x squared. Okay, copy the minus. Circle and point this guy. Something's got to cancel, and I wish I had more space. I got some more space here. The x is cancel. X is cancel. Now what survives? What survives is the 2 and the x plus 4. That's what survives here. So 2x plus 4 multiplies the 3, gives you 6 times x plus 4. Okay, so let's analyze this because it looks kind of sloppy here. The x is cancel. What survives is the 2 and the x plus 4 bundle. That 2x plus 4 bundle multiplies the 3 to give you 6x plus 4. We're going to clean that up later. This circle and point this guy with relative to this, well, what cancels? The 2's cancel. When the 2's cancel, what's left over is x plus 4. That x plus 4 hooks up with the x, giving you x squared, x plus 4. Okay. Let's see. I'm going to pull out, I'm going to multiply this out. 2x squared minus 6x minus 24 over that x squared, x plus 4. Let's see if we see something like that in the answers. We get to pick them. The only one that has an x squared x plus 4 is this guy down here. And I think this is the answer, because if I pull out a 2, because these are all even numbers, I'm left with x squared, divide 2 into 6, I get 3, 2 into 24, I get 24. The signs look good. I'm going to go with B. Check your answer. There you go. Okay, there you go. Only 3 more in this homework. Not too bad. Not too bad. Let's clean this up a little bit. Get rid of this. And this is not too bad at all. File, new. I mean, after what we just went through, this is going to be an easy breezy problem, because I got the q plus 5. That is a bundle in itself, divided by 5q. Divided by, here's the mother, q minus 4 bundle divided by q. So, what do? You take a look. These are the babies. And let's see. What's the common denominator of the babies? It's got to have a q. It's got to have a 5. So I'm going to multiply top and bottom of the mother by 5q. 5q. I'm going to get my answer ready here on the side. Maybe I don't need one that big. Let's see. Circle and point. Bang. The 5 q's, 5's cancel, q's cancel, leaves you with a 1. 1 times that bundle up top. It looks like it's q plus 5. Q plus 5. I don't know what that is. That's a little smudge. Okay. Down here, circle and point. Q's cancel. Leaves you with 5. 5 times that bundle is 5q minus 4. And you know what? I'm going to leave it like that. Leave it like that. You can't really, this is a bundle in itself, and there's nothing you can do. Nothing cancels. Nothing cancels if the bundle. So I'm just going to leave it exactly like that. I'm going to enter that q plus 5. And on the bottom, I'm going to write 5. Q minus 4, close it. I mean, I could have multiplied through by why do the extra work? You're not going to get credit for extra work. So there you go. Just 2 more, and this section is done. Let me do a quick scan of the next one. Oh, looks like a word problem, the next one. So we're almost done. We're almost done. And you know what? Just to save a little bit of time, I think I'm going to just use the same palette here. Move this up a little bit. And I'm going to copy this. 2m squared plus 7 over m 10 plus 5 over m. And then this is a big bundle. That's a big bundle. And so I look at all the baby fractions. M squared, m, and m. What's the lowest common denominator of m squared, m, and m? It's got to have an m. The common denominator has to have an m. And I'm going to multiply. And it's got the highest power m you see is a square. So I'm going to multiply top and bottom of the mother by m squared. I'm going to use my circle arrow approach. Circle arrow. So just focus your eyes on those two and those two alone. M squares cancel, leaves you with 1. 1 times 2 is 2. Copy the plus. Circle and arrow this. M's cancel. 1 M cancel, leaves you with an M. That M hooks up with the 7 to give you 7M. Same deal here. This is going to be, Well, nothing can. There's no cancels because 10's not a fraction. This is a straight 10m squared. Plus, circle and arrow this. M cancels. If m cancels, leaves you with 1, 5m. Okay, you always have to worry. At least I got the babies gone. The babies are gone here. That's a bundle, and that's a bundle. And you'd say, well, geez, there might be the possibility that if I factor something, some bundle will cancel, and nothing's going to happen. If I pull out a 5m from here, because that's the best you can do in the bottom, 5m, I'm going to have 2m plus 1, and that has nothing to do with 2 plus 7m, so not going to affect it. I mean, this is the answer. That is the answer. So I'm going to take this and say 2 plus 7m divided by 10m squared plus 5m. Check that answer. Fantastic. And then we have a little word problem, which is not much of a word problem. And I think I really need another sheet of paper, virtual paper here. File, new. File, new, okay. Come over here. The long and the short of it is you could read all these words, but they came up with an expression that describes how two people can paint a house and how long it takes. So we'll just accept their expression, and they want us to simplify this expression. So it's not really a word problem. It's just a problem like we've done before, just disguised in a bunch of words. So they want you to simplify this. And there's nothing new to this. What's the parent? Well, the parent is the overall thing. And that parent, I'm going to exaggerate the division of the parent by showing you that the parent might have just a simple 3 at the top, but on the bottom it has a couple of baby fractions. Regardless of where those baby fractions are, you got to find the lowest common denominator of all the babies. So I'm going to bundle this. What's the lowest common denominator of m and n? Well, mn. And you're going to multiply top and bottom of the parent by mn. And that's equal to, we'll put our answer down here. This is, if we got to do a circle arrow here, just to be consistent, 3, nothing cancels because 3 is not a fraction, so 3mn. And now something pretty is going to happen here because, the m's will cancel, leaves you with n. N times 1 is n. Copy the plus. And then we circle and arrow this. And in this case, n's cancel, leaves you with an m. M times 1 is m, and that's it. That's the answer for that problem. And I think I skipped one. The video is not all that long. Let's go back to the one I skipped, just in case there's an issue. So I'm going to go n plus, I said it was easy. Let's see if that's right. Let's put that in there. Nice work. I think I skipped number 2. Yeah, I skipped number 2. Let's do number 2. All right. I thought the video would go longer than it did. So let's say f plus 4. And it happens to be a bundle, so I might make a bundle out of that. Divided by 3. And the mother, see, this is the mother fraction, has this as a division. F minus 1 bundle divided by 3. Okay. So, what do we got here? Of all the babies, that's the baby up here, and that's a baby. What's the lowest common denominator of all the baby fractions? It looks like it's 3. You're going to multiply the top and bottom of the baby fractions. Well, the top and bottom of the parent. The top and bottom of the parent by 3. We're going to use that circle and point technique. 3's will cancel, leaves you with 1. 1 times that bundle is simply going to be, well, 1 times anything is simply what's that anything, f plus 4. Ditto on the bottom here, circle and point that. 3's cancel, leaves you with 1. 1 times that bundle is f. I told you it was easy. It was easy. Don't think that you're going to divide those f's. Please don't do that. I'll be very upset because those are bundles. I'm not showing the bundle because those bundles aren't multiplying anything else. So there's no need to waste the mouse on printing parentheses. So f plus 4, and then we've got f minus 1. Check your answer, and we managed to get all 10 right, and you can too. You can get these right as well. It's the circle and arrow approach. Okay? And so enjoy that homework. I told you this would be easier than section 7.3, because I think it is a little bit easier than section 7.3. 7.3 was a pain. All right. We'll do that homework, and then we'll go off and do section homework 7.5. Take care.